structural engineer. So structures is the study of what holds up buildings, what supports loads, what keeps it from moving, etc. Now, is that the only part of scientific parts in a building? No. What else do we have?
How the space, the size, how the support of the walls is made.
Okay, that's still the structure. That's how to hold it up. What other kind of things in a building might we have to design that are technical? Yes?
The floors?
The floors, that's part of the structure.
Air and heating.
What'd you say?
Air and heating.
Yeah.
Air and heating, yes. Mechanical systems, okay? Things that make it hot, cold. Also goes with that, lighting, electricity, okay? So architectural engineers do all these different things, and there's different types of architectural engineers. So first we're going to kind of talk about the loads and buildings, okay? And we're going to use you as examples, okay? So we're going to be the building blocks. So,
Okay.
so everybody's got their sheet here.
So you guys are going to help us read this, and then we'll kind of stop and go. So who'd like to read the first paragraph? Okay, Rand, first paragraph.
Most buildings are built on vertical supports known as posts or columns, and horizontal supports called beams or lintels. The distance between the two supports is called the span.
Okay, so we need some volunteers, 2 volunteers. Now everybody's going to get a chance to volunteer. So, whoa, you stood up. Okay, come on up here. You're halfway here, and you come up here. Okay, you guys stand and face each other. You're going to be our supports. So you're going to hold this, right? So we're going to. These are our columns, right? And this is our. What did you say it was?
Beams.
Beam. So, what is the distance between the columns? You said the span. Okay. So keep going. Somebody else want to read the next paragraph?
Okay, you want to do the next paragraph?
Right here.
Yeah.
Right here.
When weight or load is added to the center of the beam, it will sag. This sag is called
Deflection. What'd you say? That's exactly correct. Deflection. So now they're going to hold it, and we're going to put a load on it. Oh, what happens? It sags and deflects. Now, is that good? No. So we want to make sure that the building doesn't sag or deflect. So there's different ways that we could make this stronger. Now I'm going to ask you, how do you think we could make it stronger? This ruler. Yes.
More supports.
More supports or
Bigger beam.
bigger beam? We don't have that, so we might have to put the support, more support. Look at it. Go ahead. Put another support there. There. That's a good idea now. Whoa. Now if they hold it, see, now it doesn't move as much, right? So that's one way to.
I don't know. Less load.
Less load, but we can't really just say we can't put less load on the building. It's got to have a certain amount of load, right?
You could put it on the edges instead, which
Okay.
helps weigh it down.
So 2 people said that. Somebody said use a bigger beam, but we don't have a bigger beam. But I'll let you let go of that for now. Turn it the other way. You're saying turn it the other way. That's the same beam.
No, that's not what I'm saying like put the weight. Put the weight on the.
Oh, near the end.
Edge.
Yeah, but again, we can't tell people you can't walk out here. So we can't tell them where to put the load. The load goes on the structure. So we can't say don't put more load on there. So that's a good option, but we still have to load it. But if we turn this beam this way, does it change it? Who said no? Who said yes? No, I want you to go short span, just one hand. Okay.
That kind of depends.
Well, do you think? Well, don't give it away. Is it going to deflect the same if I put it like that?
No, it's going to be stronger because it doesn't have, it can't bend as much because of the way.
Why does it do that? I guess that's the question. Why does it? Oh boy!
Don't break it.
No, see, what's it actually doing? Does anybody know what this is? Ooh, that's interesting.
Yeah.
It's twisting. Wow. I don't know what that is yet, but the point is, it didn't move down. It didn't sag, did it? I put a lot of load on there. In fact, what it really did, it twisted But it actually did something we call buckle, okay? And can everybody see that? Can I push it down and move sideways? Come over here. Come up here for just a second. Everybody come up here for just a second and watch. You guys put it down just a little bit so everybody can see it. Bring it down. Now watch what happens when I push it. It actually, instead of go down, it goes sideways like that. Okay, it buckles. And when I hold on to it real tight, watch what happens. It twists. You see this one goes that way and this one goes that way. Now why does it do that? Okay, you guys can sit down for a minute. Let's think about that for a minute. Why does it do that? It's definitely a lot stronger. Yes. Go ahead. Why do you think it does that?
Because it's the thing that is going to be easiest for the beam.
It's the weakest direction, or it's the most flexible direction. Now, so we talked about the beam, but before we go on, I want to talk about the column. And there's not a lot about it in the column, so I want to talk about the column. And this is a beam, and what makes it a beam? Let me ask you that. We loaded it this way, right? What's a column? Straight which way? Up. And how is it loaded?